Okay, guys, question 1 is what we'll be looking at in today's lesson. So let's see. What I'm going to do very quickly is to read through the given statement and at the same time have a look at that diagram, and lastly take you through the questions. But most importantly, I'm not going to be solving any questions, I'm not going to be doing any calculations, but what I'm going to do is just to take you through those questions in terms of how you answer the questions. Very, very much important, ladies and gentlemen, on that one. So the statement reads as follows: A, B, C, D. Where's A? Okay, there is A. Where is B? Oh, there is B. C. Oh, there is C. D, 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 D. There is D. Okay, so A, B, C, D is a quadrilateral with vertices. Remember, with vertices refers to the corners. So this quadrilateral with vertices, A, remember, A being a letter, it's a point having the coordinates 5 and 1. B, it's a point having the coordinates -3 and 5. C, it's a point having the coordinates -1 and -5. D, being the last point, it has the coordinates 9 and -7. A very short statement. Let's maybe try to have a look at that given diagram. Something that you might need to be aware of. Let's see. You've got these two lines, which actually tells you that you might find that those two sides are equal, and you do know very well that when having equal sides, it has to do with the midpoint formula. So now let me look for something else. I'm just not sure of what else needs to be explained, but I think all that we can see is enough for us to be able to start looking at the questions and see how far we can go. It looks like a complicated diagram, but you might find that when you look at the marks allocated to each question, it's not that much complicated. So let me quickly scroll and have a look at the questions. So let's start with those questions that we can see. The first question, it says, determine the distance AB, and this question is allocated 2 marks. In this case, examiner said the distance and not the length. You use the distance formula. I assume at this point in time you do know very well that the distance formula is that easy one that you just need to always remember to square those, because if you don't, you are going to get the wrong answer. So easy, you just need to know where is point A, there is point A, and where is point B, there is point B. So that means this is the distance that you would have calculated after substituting those points. Then you score yourself 2 marks for that question. I think it was a straightforward question, easy 2 marks. So now let's try to move on to the next question. Remember, guys, analytical geometry, it's not like it's a complicated chapter. It is really not complicated. It's just a matter of you understanding how questions are being asked and what exactly is expected of you. The moment you see a question allocated 1, 2, or 3 marks, just know it's just a matter of you identifying the correct formula, correct substitution, correct final answer. If they specify to say leave it in sat form, for example, you need to just make sure that you follow the instructions. So very quickly, also allocated 2 marks. Let's try have a look at that question. Calculate the gradient of BD. Where is B? There is B. Where is D? There is a D. I think it's also a straightforward, easy question. You know the formula. Change in Y over change in X. What you need to remember is that alphabetically, B comes first, D comes second. Therefore, you can use D as your second values, meaning X2, Y2. Then there, X1 and Y1. Plug on your formula, punch on a calculator, and that's how you calculate the gradient. Easy, 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 easy. So now let's see. Very quickly, let's move on to the next question, being question 1.3. Also, that question is allocated, it's not 2 marks but 3 marks. So let's see, 1.3, determine the equation of BD in the form y is equals to da 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 da. So let's see, where is B, where is a D? That same line, B, D. They want you to determine the equation of that line in that form. Obviously, it's a straight line, so that means it has to be in this form of y is equals to mx plus c. But now, what is the gradient? I think we have calculated the gradient there. What I know is that for that line, you are going to have a negative gradient. How do I know? At all the times when you have a line which ends in a quadrant number 3 and quadrant number 4, it will always have a negative gradient. But for a gradient having a or ending in quadrant number 3 and quadrant number 1st, it will have a positive gradient. So again, let me guess the gradient of that line BD. It doesn't need to be correct, it's just for the purpose of making sense. So obviously, when you determine the equation of that line, let's say you calculated on your previous calculation there, the gradient to be, let's keep it simple and say -2, then you have negative 2x plus c. So now you need 1 point in order to determine the c value. So you can say add, it seems like you've got 2 points there. You can use that point or that point. It's up to you which point you use. Maybe you can use point B or you can use point D. Then you substitute your y value, you substitute your x value, you calculate c. Most importantly, your c value has to be a positive value because that line cuts the y axis on the positive side. The moment you get a negative c value, then you suspect something went wrong on your calculations. So very, very much important, ladies and gentlemen, on that one. Most importantly, as soon as you calculated your c value, make sure that you write the answer in the form of y is equals to your gradient x and your c value. I might need to scroll down and then we look at the next question. So it seems like we still have some more questions there, but let me just do that. Let's see. 1.4, it says determine the coordinates of M, the midpoint of BD. BD again. So let's see. There is B and there is a D. So this is what we are looking for. And most importantly, they did indicate that that is equals to that, meaning M is actually the middle point of BD, which means you will need to use the midpoint formula. Obviously, the midpoint formula, you can just say M because there you are actually looking for the midpoint. Then you can have your x1 that you need to plus it with your x2. You divide it by 2. You do the same for the y values. Y1, you plus it with y2 divided by 2. Obviously, x1, it could be the x value at b, and then the x value at d. You do the same there, the x value at b, the x value at d. That's how you calculate the coordinates of M being the midpoint of B, D. So I think that also, it was a straightforward question. So very quickly, let's move on to the next question. Now we are proving. What are we proving now? They say prove that. This is the question. 1.5. Prove that in triangle AMB, it is angle M that we are trying to prove that it is equals to 90 degrees. Very, very much important, ladies and gentlemen, on that one. And also, this question, it's allocated 3 marks. It makes it very much easy when you try to redraw that. Maybe let's move from point A to point M to point B and see how that triangle looks like. So let's see. From A to M, and then there, and then let's go back. There is the triangle. So we are trying to prove that that angle there is 90 degrees. How can we possibly do that? Obviously, we do know that for lines forming 90 degrees, they must be perpendicular to each other, which means, let's see, the gradient of that line, when you multiply it with the gradient of that line, it has to give you -1. So that's how you can prove that angle M in that triangle is equals to 90 degrees. So that means you are therefore going to say the gradient of, let's say, BM, when you multiply that with the gradient of AM, they must give you -1. That means you do need the coordinates of M in order for you to perform that calculation. But if you remember, on the previous question, we did calculate the gradient of that line. Remember, the gradient of BM, it is the same as the gradient of BD. Because BM and MD are collinear. BM and MD are collinear, meaning it's just the same line being extended. So that means you won't need to worry that much to calculate the gradient of that line. You already know, you just need to calculate the gradient of that line. You obviously calculated that point M on the previous question. So you use those 2 points, M and A, to calculate the gradient, of which once you are done, you multiply them together. Therefore, it would mean AM is perpendicular to, let's see, AM perpendicular to BM. I think very quickly, let's jump on to the next question. Just I need to get something to eat, honorable members. Since I woke up, I've been preparing to work, but I think I'm almost done. Very quickly, let's move on to the last question. I will need to scroll. Yes, it is the last question, which says, find the coordinates of E. Where is E? There is E. Find the coordinates of E such that A, B, E, C is a parallelogram. 4 marks. Let's see. Let me do that. Sure. I'm just hoping that it's not a complicated question. Find the coordinates of E such that A, maybe let's try to redraw that to go from A to B to E to C, and then let's close it there. No, it doesn't take the correct shape. I'll need to remove it, and then I'll manually draw that. So from A straight, and then from B straight, and then from there to there straight, from there to there straight. Okay. Now let's see. If we are having a parallelogram, what we know is that the diagonal lines, so that means that to that, and then also from there to there, they have a common point. It doesn't seem to be complicated. I think we have done this from the previous question, where you need to use that point B and that point in order to calculate the midpoint, and that midpoint, it's a common point for A and E. So now let's see. Once you've calculated that common point being the midpoint using the midpoint formula, you are still going to use the midpoint formula again. Maybe let me do this so that it makes sense. You have calculated that point having x and y. You are still going to use the midpoint formula to determine that point. Remember, you are therefore going to have x at, what can we call that point, Mar? Maybe let's call it point Q. Yes. So that means the middle point there at Q, its x value, you're going to say it's x at A, that you need to plus with x at E, and you divide it by 2. You do the same for y at Q, you will need to say y at A, that you need to plus it with y at E. What happened there? I'm just not sure of what happened. It seems like it erased all my information. But I think you guys have got an idea of where I was going with that. Let me try check if I can quickly redo that. So that means this is what we had from there to there to there to there. Same thing again. We'll need to draw it manually. But I'm pretty much sure that you guys have got an idea of what I'm trying to achieve there. I need to scroll down a bit. So, okay. So, from A to B, there, and there. So, what I said was that and also that. It's got a common point being that one. And that point, we assumed it to be Q. So, for the y value, you're going to say y at a Q is equals to y at A, that you plus it with y at E, and you need to divide that by 2. Let's see. Y at Q, you would have calculated it from those 2 points. Then you're going to substitute it there. You substitute y at value there. Then you just cross multiply, and then you take this to the other side. That's how you calculate the y value at E. You do the same for the x value, and that's how you score yourself full marks for that question. It looked a bit complicated, but it seems to be an easy question. So guys, that brings us to the end of our lesson for today. I think I will need to get something to eat. Otherwise, I wish to actually complete all these questions. So I think I'll just have to jump on to the next question. I think I'll eat a bit later. So this is that time when I need to sign out and say, guys, I do thank you very much for joining. My name is Desmond, and I'm out.